Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. I suppose this short video, the second one dealing with the Euclidean algorithm, we're going to try to find the greatest common divisor of two, let's say, larger numbers. And in this case, in the previous video, the numbers that we find the GCD of, the GCDs, the greatest common divisors, were all equal to 1. In other words, the two numbers were relatively prime to each other. But in this video, we're going to try to find the GCD of, let's say, 12,378 and 3,054. Okay, so using the Euclidean algorithm, what we do is we take our largest number, okay, in this case 12378, and we ask how many times does 3054 divide into 1378. Okay, so what we know is this is that 12,378 divided by 3,054, that goes in 4 times. So what we know from the Euclidean algorithm, or the division algorithm, is that 12,378 must be equal to 3,054 times 4 plus some remainder. To find the remainder, we take 12,378 and we take away from it 3,054 times 4. Okay? So we have 12,378 minus 3,054 times 4 gives us a remainder of 162. So our first pass of the division algorithm tells us that 12,378 is equal to 3,054 times 4 plus 162. Okay, so once we've done that, what we do is we take these two numbers and we ask how many times does 162 divide into 3054. So what we know is 3054 must be equal to, well, how many times does 162 divide into it? So we have 3054 divided by 162. Well, it goes in 18 times. So 3054 must be equal to 162 times 18 plus some remainder. To figure out the remainder, we take 3054 and we take away from it 162 times 18. So we have 3054 minus 162 times 18 gives us a remainder of 138. We continue, we take 162, we divide it by 138, so we have 162 must be equal to, well, how many times does 138 go into 162? Well, it goes in once, okay, with a remainder of, well, 162 minus 138, so 162 minus 138 gives us a remainder of 24. Okay, then we take these two numbers and we ask how many times does 24 divide into 138. So what we know is 138 must be equal to 24 times some number. Well, 138 divided by 24, it goes in approximately 5 times, so it's equal to 5 times this, okay, plus some remainder. Well, 5 times 24 is 120. 120 taken away from 138 leaves us with a remainder of 18. Then we take these two numbers, so how many times does 18 divide into 24? Well, it goes in once, so 24 must be equal to 18 times 1 plus some remainder. What's the remainder? Well, 24 minus 18 times 1, which is 24 minus 18, gives us a remainder of 6. Then we continue, we take 18 and we divide by 6, so 18 is equal to 6 times 3, because 6 divides into 18 3 times, plus a remainder of 0. And we stop when we get no remainder, okay? A remainder of 0. And what we know is that the greatest common divisor is the last non-zero remainder in this particular process of continual applications of the division algorithm. Okay. Let's have a little look at this. So really what we're saying here is that the GCD of 12378 and 3054 is equal to 6. So the largest number that divides into both of these numbers is 6. Now, how does this process work? How are we sure that the last non-zero remainder is this greatest common divisor? Okay, well, let's just abstract away for a moment. Okay, we have two numbers, 12378, and we have 3054. Okay, So if there is a greatest common divisor between these two numbers, okay, what we know, it must divide into both of these numbers. So it must divide into 1, 2, 3, 7, 8. And it also must divide into 3054, in which case it must divide into 4 times 3054. Okay? But because it divides into 3054 and 1, 2, 3, 7, 8, it must also divide into 162. Okay? So based off the division algorithm, if we find a divisor that divides into 1, 2, 3, 7, 8 and also 3054, okay, well clearly it'll divide in here. It clearly divides in here because it divides into 3054. But because it divides into this, it must divide into everything over here. So hence it must divide into this and this. So once again, we have 3054 and 162. This greatest common divisor divides into both of these, divides into these two. So if there is a greatest common divisor, it's going to divide into these two. Divides into this. It clearly divides into this. So hence it must divide into the remainder. And we continue in this process and with this particular argument, so that each time we move down, okay, what we have is we have the last non-zero divisor, is a number, okay, that divides into all of these numbers back up the chain. I know that was probably a little bit convoluted there, okay, in relation to this, but really what we're saying is that multiple applications of the division algorithm, when we get down to the last non-zero remainder, that this last non-zero remainder is this greatest common divisor that we're looking for. Okay guys, I hope this video was a little bit helpful and demystified the process with respect to calculating the greatest common divisor of two numbers. The next video in relation to the Euclidean algorithm, what we're going to look at is what's known as the extended Euclidean algorithm, which is going to help us to find the inverse of a number modulo a particular alphabet size. Okay, so once again guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this video was somewhat helpful.